Fasteners inside of the engine are one of those components that are often overlooked, but they can be so critical to the strength and reliability of your engine. We're here with Chris from ARP to talk a little bit about the ins and outs of aftermarket fastener technology and materials. So Chris, for a start, one of the most stressed components inside the engine is, of course, the connecting rod, and then in turn, the connecting rod bolt is one of the most stressed fasteners. So if we can concentrate on just that one component for a moment, obviously the ARP product has sort of become a relatively common addition to a range of aftermarket manufacturers' rods already. But these bolts are available in a range of different materials. So can you talk to us a little bit about what those materials are for a start?
Well, we do offer a range of materials. We have the 8740, ARP 2000, L19, Custom Age, and MP35. Those are our standard go-to materials that we use. They're different in strength, starting at 190,000, 200,000 PSI, clear up to 260 to 280,000 PSI.
So we quite often see the 8740 and maybe the ARP 2000 seem to be sort of the go-to, we'll call them shelf stock rod bolts. And again, the aftermarket manufacturers, that tends to be their go-to. However, we can potentially upgrade to something like the Custom Age 625 Plus material, which is stronger. The question we quite often get asked is, well, how do I know when I need to upgrade to a stronger material? When is the off-the-shelf ARP 2000 no longer enough?
Well, the proper way to do it is to go ahead and do a load calculation. So we'd get the numbers based on the rod. We'd compute what the actual load is that's required for the bolts to hold the cap onto the rod to pull the piston back down into the hole. And then we would base our choice on that. Obviously the 8740 is a very cost-effective entry-level package, but if you need to determine the correct fastener for what you're doing.
Just coming back to something you've just mentioned there, and it's sort of I think a common misconception. A lot of people would think that when they're rating rod bolts or choosing rod bolts, it's related to the amount of power the engine produces, but it's actually not really that relevant, is it?
No, sir, it's not. It's more relevant to what your reciprocating weight is on the between the top half of the rod, the piston, the rings, pin, and the RPM of the engine.
And that's really because the stress that's placed on the rod bolt is when it's decelerating the piston as it's moving up towards top dead center on the exhaust stroke, and then the con rod and therefore the rod bolt has to sort of arrest that movement, slow it down, stop it, and then accelerate it away from top dead center again. So again, nothing to do with the actual cylinder pressure during the power stroke, correct?
Correct. I mean, if you had something pressure always on the piston, you could get away without even running the cap as long as you keep the oil on it.
All right, so obviously you mentioned there that there is a cost deficit. Just going to the top shelf Custom Age 625 Plus, I mean, that's going to give you the best product available for your application, but maybe you don't need that. Sort of, can you give us an indication between ARP 2000 and Custom Age 625 Plus? What's the sort of price point difference?
There's going to be a basic cost of your ARP 2000 bolt's going to be $8 per bolt, up to on a Custom Age, you might be at $25, $27 a bolt.
Okay, so it's something that does need to be factored in, and of course it's not going to be right for every build, but in the big scheme of things, if you're pushing the boundaries, the extra for a set of rod bolts in Custom Age 625 Plus may be cheap insurance?
Correct, and that's what we would call that. We do advertise it that way. Sometimes it's just cheap insurance. And then one has to take and consider the rod design as well, because if the rod's poorly designed, then it puts more stress on the bolt. So if you have a good joint at the parting line, there's more integrity there. You know, the bolt's going to be able to hold up better because it won't have that flex in the joint.
Now, one of the elements with some of these more exotic alloys of material that are used for the likes of Custom Age 625 Plus, just to name one, is that they can be susceptible to hydrogen embrittlement, which means we do need to be a little bit mindful of how we actually handle and deal with these bolts during installation and removal. For a start, what is hydrogen embrittlement? How does it affect the fastener?
A hydrogen embrittlement or stress corrosion failure is created when there's basically it's a rust molecule or a spot, and it can be caused by the salts in your hands or moisture or exhaust gases or steam, and some different materials are more susceptible to this kind of failures, and it's more based on the strength level that you heat treat the part to. So if you're using that material in a transmission shaft, you're not stressing or loading it. It's a really durable and good material. You have very few, if any, failures in a shaft type application with the material. But whenever you heat treat it up to a really a high level, such as 260 ksi, now it's kind of like pulling the hammer back on your gun. You know, you're really kind of, it's a loaded gun, and now if you induce salts or moisture or exhaust gases to it, it can trigger this rusting effect to happen. And when it does, the molecule basically gets into the material, it expands, and it just splits the fastener apart.
So it's something to understand, because dealing with these parts with our bare hands can have that effect. It's not to say it's going to, but easier solution, just avoid the problem altogether, use latex gloves or something like that when we're handling these fasteners?
Yeah, and when you're using the materials in a rod bolt application, let's face it, they're usually in oil. If there's water in there, you're in trouble. So if you try to handle them good, keep them well lubricated, and that's your best way to handle it. There's very few issues with it, but you do get them occasionally. I know we're talking about connecting rod fasteners, but if you use that same material in a head stud application, now you're putting it in a situation where there is usually moisture. If you're pushing a gasket, you're going to get steam on it, you're going to get exhaust on it, and that's where that's the wrong place for that. So that's where I always want you to either use an ARP 2000 material or go up to the custom H625, because you just eliminate any possibility of that stress corrosion.
Okay. Now, one of the other topics I wanted to discuss is the way we actually tighten these fasteners when we're installing them. And again, for our explanation here, let's talk about connecting rods. They're a little bit unique in that in most instances we do have access to both ends of the connecting rod bolt, which is an advantage because we can use the stretch method. We can actually fit a stretch gauge around the bolt. So more typically we see fasteners being tied into a specific torque. What are we actually trying to do with the fastener when we're tightening it down? What's actually happening to that fastener to make it work how is intended?
Well, in order for a fastener to work, you have to apply load. So as you tighten it, the bolt, the threads, the bolt elongates, and it's critical to have the bolt in its happy spot. So the way I always like to explain that is if you had a throttle spring on your car with, in the old days, a carburetor, and if you unbolt your carburetor and you go to take it off and you forget to unhook the spring, and when you pull the carburetor away, you take the spring and you bend one of the coils. Well, effectively you've yielded that spring, so you bent the coil. So now when you put the spring back on, it's lost its load. It's no longer effective for a return spring. The bolt, a rod bolt, or any fastener, you want to work just like a spring. So if there's no tension on it, it doesn't close the throttle. If you put too much tension on it, it's going to yield it. So you want the throttle spring on a car is a good example, because they'll go millions of miles if it's not in a salt environment. You'll never have a problem. It'll always have the right tension. It'll always expand and contract back to its original length. So with the rod bolt, you want to install it, and you're looking for a target load, and we calculate that when we manufacture the fastener. So if you're looking for that, say that 14,000 pounds of clamp load, we know that the bolt has to elongate 6.5 or 7 thousandths to get in a given application to get to that load. When we don't have the ability to have every customer with a stretch gauge, we generally have to formulate a torque for that. So what we'll do is we'll use a fixture, and we'll take the factory rod or the aftermarket rod, we'll put it in, and we'll start torquing that bolt, and we'll figure out where the torque needs to be to get that proper load. And of course, ideally, we'll verify that by stretch.
So there's some downsides in just using that torque method. So essentially, to sort of join the dots on what you've been saying, we're using a correlation between the torque that we're applying and the amount of stretch that the fastener will be achieving, and it's that stretch we're aiming for. And the problem with that is, that correlation or relationship isn't always perfect. I mean, it can be affected by the type of lubricant you're applying to the threads, the condition of the threads, etc. Correct?
Completely. That was the next thing is that the lubricant's very critical. If you were stretching the bolt, you could put it in dry if it didn't gall because you know where it's going. But as you have the underhead friction, the friction in the thread, it all comes into play. So, and if you have the rod that you've machined it, say you're using, we prefer our ARP Ultra Torque. It has a certain friction coefficient, but you got somebody else. So I just like to use motor oil, or I like to use anti-seize, or I like to use, well, all those friction coefficients are different. And so now you're saying 70 foot-pounds is a given your torque. Well, you have no idea where you're at. And if you do take your rods and it could be a brand new set of rods or whatever rods you got, and you put the fasteners in it, you either torque them or you stretch them, and you take your dial bore gauge and you check the rod per round. Now, if you just put another 10 foot-pounds on it or take 10 foot-pounds off, you'll be able to generally see where the rod's going to go out of shape, and then you're going to have a problem. So if you're putting your engine together and say you took your rods to the machine shop and had them size your connecting rods, but you didn't know what lube he used, you don't know if his torque wrench was calibrated or not, and you get home, it's kind of a crapshoot per se, is what you're going to get for results.
I mean, going on from that as well, something that's really easy to overlook on that same sort of basis is if you are upgrading from a particular rod bolt to something stronger with more clamping force, as you mentioned in there, that additional clamping force can result in distortion of the bearing journal. So often when we do this, the rod will need to be resized to make sure that housing is truly round, correct?
Correct, and that's important as we talk about when you said we have say a 7/16 1/600 length rod bolt. I mean, we have that in 5 different materials, and you could effectively take one bolt out and put the other one in. But if you put it in and install it to the proper clamp load, you could close the end of the rod up, a thousandth or a thou and a half, or make it. I've done these tests myself, and where, on a small block Chevy connecting rod, of one of many of the several manufacturers out there. Usually a small block rod will close up when you change the bolt or you properly stretch the bolt. On a big block Chevy, it moves the parting line out so much that the rod's not savable. So
these are the things that people need to understand that maybe aren't initially obvious until you've actually gone through this process and you've seen these results for yourself. The last element I want to talk about is the life expectancy of these bolts, or when they should be reused, or when they need to be thrown out and a new set going. So let us know, what's the story here? Are they indefinitely reusable? Do they have a life? How many cycles can we get? What do we need to know?
Mm-hmm. That's an important question. As long as the quality of the threads, the quality of the wrenching, there's no corrosion, and the history of the bolt, it's always been installed properly. It's always at its original length, its free length. The bolt should be reusable.
So this is a difference with the ARP torque specification from memory, 75% of the yield strength of the bolt. And I don't want to get too far into the sort of the engineering aspect of yield strength, etc. But essentially, you're stretching that bolt within its sort of plastic area of deformation, so it's going to return to that original length. And the flip side of that is a lot of factory fasteners will be a torque to yield style fastener, where you are actually stretching it beyond the yield point, which means that when you undo that fastener, it's permanently deformed, it's stretched, so you can't reuse those fasteners. That's correct?
Correct.
All right. Great to get some insight onto these fasteners and hopefully share a little bit of information that others can benefit from there. If people want to find out more about the ARP range of products, or maybe get a correct connecting rod bolt specified for their build, how are they best to do that?
You can go to arp-bolts.com.
Perfect. Thanks for your time, Chris.
Thank you.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.